Our objective is to be able to write linear equations from situations, and our warm-up was to write our own linear function, or an example that models a linear function. For example, how many days till the end of school would be 1. Always goes down by 1 until we're there, right? Okay, so we're looking at 1.3 notes. We're reading right here, Mariette, a dendrochronologist, observed that some tree stumps have rings that are close together while other tree stumps have rings that are farther apart. Why does a tree stump have rings? So, real quick, why does a tree stump have rings? Do y'all know? Okay, so the rings tell you basically how old the tree is. Every year basically adds another layer onto the tree, so it grows out as it grows up. Okay, so what might cause it to be closer together or farther apart? Now, why do you think there might be smaller or larger rings? Okay, how much it grew that year? What would prevent a tree from growing a certain year as much? Water it needs. What else does it need? Sunlight. So maybe it was a dark year or something. I don't know. I'm not a dendrochronologist, but yes, that's right. It's whatever made it grow or not grow that year. Maybe there was some good fertilizer, whatever. Okay, but let's talk about an example here. Each year during the growing season, trees grow larger by adding another layer of cells just beneath the bark. This layer is called a tree ring. Because a tree ring is added each year, scientists can determine the age of a tree by counting the number of tree rings that are present. Take the pass. However, not all tree rings have the same width. Trees grow more when there is plenty of rain and the soil is fertile. Scientists can draw conclusions about temperature and rainfall for a particular year based on the width of a tree ring for that year. So obviously, if you got a big old ring, hey, it must have been a rainy year. Okay. So Mariette measured the width of the tree rings from a core sample she took from a post oak tree in the Brazos River Valley of central Texas. From the tree ring width, she calculated the radius of the tree. The table below shows her results. So we got these results right here. Let me grab this real quick. And on the next page, it's going to ask us about it, so I can have it right here. All right, so you're going to have to flip back and forth, unfortunately, but we want to calculate the finite differences. Basically, we're doing the bird beaks like this. Okay, go ahead and calculate each of these. Yes, don't assume they're all the same. I want you to actually find the difference of all of these. I'll give you a second to do that. So what do we get? So the first one, 3.1 minus 2.5 is 0.6. What about this next one? What'd y'all get on the second? Okay, 0.4. And then from 3.5 to 3.9, 0.4 again. All right, and then 0.5, yes. Okay, 0.5 again. And then 0.6. So, what do you notice about these differences? They're not all the same, but they're not super different, right? They're not like doubling or something. They're just 1.1 off here and there, right? Okay, so number 1, we did that. Number 2, are the first differences in the radius constant? Okay, so these differences are not constant, right? So, no. They vary. Now, last period was like, what does that word mean? Miss Marrero, what does vary mean? Yeah. Am I spelling it right? V-A-R-Y? V-A-R-Y. Yeah, that they're basically different. All right, y'all know what vary means? So, number 3, what is the average finite difference in the radius? Well, now, do y'all know how to find an average? How do you average numbers? Let's say I got a bunch of numbers. How would I average them up? Add them up and then, not multiply, we would divide by how many numbers we had. So basically, do you see these 6 differences? We want to find the average difference. So let's add them all up. We'll make a big old fraction here. So 0.6 plus 0.4 plus 0.4 plus 0.5 plus 0.5 plus 0.6. Now, not only do I add them up, but then what am I going to divide these all by? It's a terrible line. All right, what do I divide by? How many numbers are there? And there is 6 numbers, so divide by 6. So, let's do that. Yeah, 0.6 plus 0.4 plus 0.4 plus 0.5 plus 0.5 plus 0.6. Okay, so I add all that and I get 3, and then I have to divide by 6. So my average difference, I take all those differences, average them out, I get 0.5. Cool. Then it says to use the information from the table to write a function rule that models the data. Now, when we think about function rules, we're talking about, for linear, what's the linear equation we're used to? Yeah, y equals mx plus b. Now, do we know our m? What's the change each time, each year? What's the average change that we just found? 0.5. B, for beginning, is the y-intercept, is where we start. So on our table, where did we start? How many centimeters? 2.5, right? So again, my m is 0.5. My b is 2.5. All right, and so all we got to do is take that m and that b and plug it into mx plus b. So let's do that. Y equals 0.5x plus 2.5. Cool. There's the question. What does the slope mean? Now, we just said the slope was 0.5. What does that mean? If we're talking about rings. Well, somebody else. What do y'all think? What does 0.5 mean if we're talking about the growth of the tree and the rings and blah, blah, blah? Again, we're talking about what the radius of the rings per what? Okay, you're basically talking about the two parts of the table. It's the radius of the rings per year. And since we're talking about age, okay, we would say that the tree grows, okay, a new ring increasing at a radius about 0.5. Okay, so here's what I had up earlier. Now, it grows about 0.5 centimeters outward, both directions, obviously, since we're talking about the radius, okay. That might be better. The tree's radius grows about 0.5 centimeters per year. Cool. So, we're going to use the model to predict the radius of the tree in 2015. So, do y'all know how to take an equation like this and turn it into a table? This is something you would have done in Algebra 1. How do you take an equation, turn it into a table? Okay, calculator, right? So let's go to our calculator. Let's go to graph. So do a new document. Don't save. And let's go to graph. Let's type in 0.5x plus 2.5. Okay, I type in my equation. I'm going to hit enter, and I'm going to see my line, but what I need is a table. What buttons do I press to get a table? Control T for table, okay? So I'm going to hit Control T, and off to the side, now I have a table. X's are on the left, Y is on the right. Horses in the back. All right, so we're looking for what year? 2015. Now, you're not going to look for 2015 on the X value, because 0 is what year? What year is 0? 2000. So 2015 is actually what year number? 15, right? So let's go back to that graph table and look for 15 on the left. So at year 15, my radius is now what? 10, okay? Now you can use your equation to get that, but this is maybe a little easier to look at the table, okay? So let's write that down. 10 what? What are we measuring in? Centimeters. So 10, and go ahead and put that down on number 3. Those are supposed to be centimeters, my bad. Okay. Go back to that table. You can find this answer. What year, what X value, will the tree be 12.5? So we'll keep scrolling. What year is this? The 20th year, but what's the year itself? 2020, okay? So year 2020 will be 12.5, and again, so how did I get this stuff? I, graphed it, Control T, look at the table. Cool. Look at 6 and look at 8. Are 6 and 8 asking the same thing, or what's the difference? They're both talking about 2015, but 8's talking about what? Circumference. Now, you should have taken geometry before. What does circumference mean? Not through the middle. Let the students answer. Oh my goodness gracious. So, circumference is around the edge, okay? Basically perimeter of a circle. So, let's see what y'all remember. Does anyone remember the formula for circumference? Pi r squared is area. So not pi r squared. C equals what? It's close. What? No, that's a linear equation. This was an equation from geometry. So no one remembers circumference? It's either pi d or it's 2 pi r. Okay? So just not squared. Okay? So circumference is 2 pi r. So all we got to do is take the 2015 radius. Wait a minute, we did that. 10. So we're just going to plug in 10 to this, okay? 2 times pi times 10. So I'll go to my new document. 2. Now pi is in the bottom left down here. Make sure I press pi times 10. And I get 62.83. And we're talking about centimeters still. Okay. We're going to skip over number 9. You can make a scatter plot with your calculator pretty easily. But we're going to go ahead and get on to the next page. So the next page is just 2 linear type problems. You can either find the equation yourself using change and starting point to find m and b, or you can use the linear regression. Either way. Oh, my nose. Go ahead and get started.